Okay, so let's have first this sample problem before we proceed to the next topic. So for number one, we have here the given the geodetic latitude of a point on a spheroid is 42 degrees north. So that is not anymore a sphere but a spheroid, and it has a flattening of 1/3. So we are going to determine the value of the reduced latitude. So let's try this one. So we have the given value. Okay, so we have a given value of, so given, oh, I'm sorry. So we have given of phi, which is equivalent to 42 degrees north, right? And a flattening of 1/3. So our required is to compute the reduced latitude. So what we know now is the relationship between the geodetic and the reduced. So we have here b over a tangent of reduced is equivalent to, what is the formula for the geodetic? That is 1 minus e squared times tangent of the geodetic latitude. So this relationship, we are using this relationship to compute the value of the reduced latitude. So what we know, so we already have here the formula for the flattening, which is equivalent to a minus b all over a. So since in the relationship we only have here e squared, right? We have here e squared and b over a. So let's make this equation equivalent to 1, equivalent to f, since we already have the value of f. So if we simplify this, f is equal to a minus b all over a. So if this is equal to f, so a over a minus b over a, right? So this is equivalent to 1. So this is f is equals to 1 minus b over a. So therefore, your b over a is also equal to how much? 1 over f. So this right here, b over a in relation to f, that is equal to 1 over f. Now, next one is for the e squared. How are we going to make e squared with respect to f? So we all know that e is equivalent to the square root of a squared minus b squared all over a. Now, if we take both the square root to make it e squared, yung atong purpose is magiging e squared siya. So we square this one and this one also. So this will become e squared is equal to, matatanggal yung square root sa itaas. This is a squared minus b squared all over a squared. Right? Then what will happen? So we simplify this one, cancel out a. This will become e squared is equals to 1 minus b squared all over a squared. So what is a squared all over, what is b squared all over a squared? That is e squared is equals to 1 minus b over a squared, right? And that, what is b over a? This one, what is b over a? B over a is equivalent to 1 minus f. Therefore, our e squared can be written as 1 minus f squared, right? Since b over a is just equals to 1 minus f, then squared. So, if this e squared here, we just use this equation 1 minus 1 minus f squared. Okay? So, let's rewrite this one. Yung b over a tangent of the reduced is equal to 1 minus t squared tangent of p, right? So in terms of flattening, so your b over a, this now become 1 minus f, right? Tangent of reduce is equal to, this is 1 minus, what is the value of e squared? The value of e squared equals to 1 minus 1 minus e squared. This is e squared. Or we just simplify this one. The whole value of 1 minus e squared. So this is, if we transpose this one and then the other one to the left side, this will become 1 minus f squared is equals to 1 minus e squared, right? So this is equivalent to 1 minus f squared tangent of t, right? So if this is 1 minus f, we can divide it by this 1 minus f. This is 1 minus f. This is 1 minus f. Cancel out. Then the left one is 1 minus f. So this is tangent is equals to 1 minus f. Wala nang square because we cancel out this one. This is tangent of p, right? And then reduced is equals to arctan of your 1 minus your f is equals to 1/3, right? Tangent of p, 42 degrees. Now then your reduced now is equivalent to, we calculate it first. So we have shift tan 1 minus 1/3 is 1 minus 1/3 times tangent of 42 degrees. So that is equal to 30 degrees, 20 minutes, and 4.82 seconds. Again, that is 30 degrees, 20 minutes, and 4.82. So let's just double check our answer if this is correct. Okay, I think this is correct. So now let's move to the second item. There is a correction. So this is delta. This is 30 degrees, 58 minutes, and 30.37 seconds. So just try to double check the answer. We have here 30, 58, 30.37 seconds. Okay. So let's have here another example for number 2. So if a point on the surface of the Earth has a geocentric latitude of 45 degrees north, so using the WGS84 parameter, so we are using this parameter for the WGS84 to compute the corresponding reduced latitude of the point. So we are given with the geocentric latitude, which is 45 degrees. The WG is 84, and we are going to find what is the parameter for the WG is 84, and then we are going to compute the corresponding reduced latitude. So let's have here another solution. Okay. So you are given then we are given with here. So meron tayong given na we have here geocentric latitude which is equals to 45 degrees north. And then WGS 84 WGS be sure you have an idea what is the WGS 84 parameter. So you are given the WGS 84 parameter A and B. So check your notes. What is the parameter for A? So as far as I remember, A is equals to 6378137 meters, and B is equivalent to, let me check if this is correct. So 6356752.314. So take note of this WGS 84 parameter. This is the common parameter being used during the board examination. Okay, so let's now find when we are required to compute the value of the reduced latitude. So using the relationship that we know, we have here B over A tangent of the reduced is equivalent to tangent of your geocentric is equals to 1 minus E squared tangent of the geodetic. So since the only parameters or the only latitude that is included in this problem is the have here the geocentric and the reduced, then we are only using this relationship to compute. Okay, so this is very basic since we already have the values. So B over A tangent of the reduced is equal to tangent of P. So since P is already given, which is 45 degrees, and B over A, we already know that one, which is 6378137, 63562.314. If you are asking where did I get this, kindly check the presentation that I gave you last time. So it is there listed the parameters for the different spheroid globally. Okay, so our goal is to compute for this one. So we can divide this by the value of B over A. So we can divide this one by B over A by B over A. And fill out this one. So your tangent of reduce is equals to tangent of C times A over B, right? So reduce is equals to arctan of the product of tangent of, let's substitute the value, which is 45 degree times what is A? A is 6378137 and B is 6356752.314. Okay, so reduced is equal to, let's compute, we have shift tan tangent 45 degrees times 6378137, 6356752.3142. 63, let me double check. Have here 6378137 6356752. So the answer is equivalent to, have here, 45 degrees, 5 minutes, and 65 degrees, 45 degrees, 5 minutes, and 46.36 seconds. So this is now the value of the reduced latitude, which is equivalent to the geocentric latitude of 45 degrees north. I mean, since this is a latitude, don't forget to write, sorry, I forgot, to write the direction. This is north. 45 degrees, 5 minutes, 46.36 degrees north. Okay, so to check if your answer is correct, the geodetic or the geocentric is always smaller than the reduced, right? And the largest one is the geodetic latitude. So look at here, if this is 45, for the geocentric, the corresponding value of the reduced is 45 degrees, 5 minutes, 46.36 seconds. So greater than ang value pag nasa reduced latitude. Since yung reduced latitude is bigger, it because nakatupaya sphere, so mas dawon iyahang angle. So reduced latitude is greater than the geocentric latitude. Okay? I think we can proceed to the next question. Have here. So if the geocentric latitude of a point in this period is 45 degrees north, determine the geodetic of the given point if the first eccentricity is 0.86603. Okay, we take note the given. We have the geocentric latitude of 45 degrees north, and we are going to compute the geodetic latitude. So if the first eccentricity is 0.86603. Okay. So we have the given value. So given tayo ng what's that again? I forgot. We're given with geocentric latitude. So we are given with geocentric latitude, which is equivalent to 45 degrees north. And then another one, we have the first eccentricity, which is equals to 0.86 and 866603. Am I right? 8666. Okay, good. And we are required to compute the value of the geodetic and the geodetic latitude. So what would be the relationship between these two? We all know that tangent of the geocentric is equal to 1 minus e squared, diba? 1 minus e squared tangent of the geodetic latitude. So since we already have given the eccentricity, so madali na lang. So we can compute the value of this by just dividing this one. We can divide it by 1 minus e squared, right? This is 1 minus e squared. So we can cancel out. This will become tangent phi, right? This is tangent geocentric over 1 minus e squared. So we can directly substitute the value since this is tangent of P. What is geocentric? This is 45. This is 45 degrees. Sorry. This is 45 degrees all over 1 minus, since this is 0.866603, we take the square of this 0.008603 only, and this is equivalent to tangent of your C. And then C is just the arctan of this value. We have tangent 45 degree over this 1 minus 0. 36 8 66603. Then P is equal to, have your calculator please. This is shift tangent 45 degrees all over 1 minus 0.866603 squared. So this is 76. This is first eccentricity. So the answer is 76 degrees. First eccentricity. So this is tangent 45.866603 squared. That is 0. 0.75. Double check ko lang ang solution. 45 divided by 1 minus 0.866603 squared. Then shift hand. Okay, so that is 76. This is 76 degree, 1 minute, and 3.85 seconds. So this is now the equivalent value of the geodetic latitude of a given point whose geocentric latitude is equal to 45 degrees north. So I hope you get the relationship between these three latitudes.